What's up, archers? All right, it is a short week, so you've only got 4 days. This is just a quick tutorial on Monday. If you're having some questions or concerns, or you can't remember how to do some of these things. All right, so the first one's just a long division problem. All right, so in here we have the dividend. Right here we have the divisor, and this is the quotient. So we're looking for the quotient. And your divisor is 13. Your dividend is 11,089. I'm going to leave the comma off just because I don't like to put that in the dividend because sometimes it messes up and looks like a decimal. All right, so the first thing we're going to do is see that 13 does not go into 11. We got to go all the way to 110. Now, you might be wondering, do I know how to do my 13s? Probably not. So you could skip count by 13s if you needed to. That gives you 26. And then I know I can probably get 4 26s into 100, which means I can probably get 8. So let's see what that works out to. So 8 times 13 is 104. Yeah, that's a pretty good section of guessing there for Mr. Kelly. All right, so then we get something to subtract. 10 minus 4 equals 6. 0 minus 0 equals 0. 1 minus 1 equals 0. So there's 6. Does 13 go into 6? No. Does 13 go into 68? It does. And I'm not going to lie to you. I'm going to go ahead and use my calculator here. And I can do 68 divided by 13 equals 5 and 2300. So 5 times 13 equals 65. We go ahead and we'll subtract 8 minus 5 equals 3. 6 minus 6 equals 0. We can stop there. And then we got to bring down this 9. 13 into 39. So I happen to know that 13 times 3 is 39. So our remainder will be 0, which means our answer for number 1 is 853. All right, looking at problem number 2 for Monday, we have what we call a tape diagram. You'll see a lot of these in 7th grade, so make sure you understand how to do this. All right, so 18, and then it's cut into 3 different sections, wanting to know what this section is. So it's a division problem or a multiplication problem. And you need to know that there's 1, 2, 3 sections. So we have a 3 and an 18. So you can either do 18 divided by 3 equals 6. Or you can do 18 as your answer. And 3 times something equals 18. That means each box will be worth 6. All right, moving on to problem number 3. It wants us to use PEMDAS. This is how I always write it, because whether it's division or multiplication or addition or subtraction, we're going to go left to right. All right, so we have 1 2/10 times 7 5/10 minus 8 divided by 4. So what I like to do, there are no groupings or parentheses. There are no exponents. Now we need to look for multiplication or division. What I'm going to do is I'm going to number my operations. My first one is a multiplication. My second one is a division. And then we're going to look for addition or subtraction. And it looks like we have 3 operations, so that'll be our last operation. All right, so let's go ahead and do 1 2/10 times 7 5/10. Remember that we'll just borrow or move these place values out and treat it like it's a regular double-digit multiplication. So 5 times 2 is 10. 5 times 1 is 5. Add that carried 1, and that's going to give us 60. And then we're going to put a place value in here because that's 70 plus 5 is what we're really multiplying. So 7 times 2 is 14. Carry the 1. 7 times 7 is 1. Carry that 8. 2, 8. 0, 0. Carry the 1. 900. So we have 900 minus 8 divided by 4. Now remember, our second operation is division, so 8 divided by 4 is 2. So 900 minus 2 equals 898. So that should be your answer for number 3. All right, now this might seem intimidating to see a 10 to the third power. This is not something that's gone over for a long period of time in 5th grade, but I'll show you how easy it is. All right, 10 to the third power just means it's 10 times 10 times 10. There's 3 of them. So you want to know, okay, well, I've got 3 place values with the 0. That means my decimal here needs to move 3 place values. So your decimal should be here, but the problem is there's no number there. I'm going to put a 0 in there. So the answer should be 1340, or 1,340. Okay, I'm going to teach you something on that one too. This one is not on the worksheet, but if it were to say 1.34 or 1 3400 times 10 to the negative 3, it's going to go to the left because we're actually going into a negative set there. So we're going to start with the decimal here. We're going to go 1, 2, 3. Again, there's no number there, so we're going to fill it in with a 0. Decimal comes here, and our new answer is 0.00134. So if it's a negative, you go to the left. If it's a positive, you go to the right. And you are just counting how many spots or how many place values you got to move that. All right, let's move on to valuing our decimals. Now, the easiest thing to do with this is just to line them up, just like this. We have 3 and 100th. We have 3 and 1/10. We have 31 hundredths. And we have 13 hundredths. Okay, what I want you to do is pretend, well, we know these ones are bigger because we have 3 holes, and we know these ones are smaller because they are 0 holes. And then we're going to look at this place value here. Okay, is 0 bigger than 1? No, it is not. So this is going to be the biggest one. This is the winner. And it wants to go greatest to least, so our biggest one is going to be 3 and 10, or 3 and 1/10. And the next one is going to be 3 and 0/10 and 1/100. All right, now let's look at our zeros. We have zeros with parts. What's bigger, 31 or 13? 31's bigger, so we're going to put 0 and 31 hundredths, 0 and 13 hundredths. So that would be the correct answer for that problem. All right. All right, so this next one wants us to model 4 tenths times 5 tenths. Okay, so what we're going to do, I'm going to start with the 5 because that just makes sense for me. It's an easier number. So 4 tenths. Please remember that this is 1/100th. It takes 100 of these to fill out the whole big box, right? So if I take 1 of these, that's a 10th. 2 of these, that's a 10th. 3 of these, 4 of these, 5 of those, okay? So that is 5 tenths. All right, now you might be thinking 4 times 5, well, that's 20, so it should get bigger. But remember, we are multiplying parts of a whole. We're not multiplying a whole times a whole. So we're multiplying basically decimals, which are fractions or part of a whole number. So I'm going to go ahead and I'm going to do 4 tenths going this way. And then what that does is it leaves us with these boxes right here. So these numbers have crossed. Make sure your model, they have both the purple and the red. And that's going to be how much we're looking at. Now the problem is I just see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I see 20 of them. So that is 20 hundredths or 2 tenths. So if you multiply a tenth and a tenth, you could write your answer as a tenth. But know that when you're counting hundredths. Each one of those boxes is a hundredth. So it can be a little confusing. But just remember that when you're multiplying parts together, doesn't mean the number's going to get bigger. All right, let's look at the next one here. This is just a multi-digit decimal problem. It's got 1 and 34 hundredths times 4 and 9 hundredths. Okay, again, I'm going to just pretend that these aren't here. We got 2 place values and 2 place values. All right, let's go ahead and multiply. 4 times 9 is going to be 36. We put the 6 down, carry the 3. 9 times 3 is 27. 27 plus 3 is 30. So we'll drop our 0, carry our 3. 9 times 1 is 9, plus 3 is 12. All right, let's do our 0. Guess what? 0, 0, 0, 0, 0. 0 times anything is 0, right? So that whole line just basically gets negated. You don't really even have to write it down. Now this can be tricky because remember the 4 has 2 place values behind it. So don't forget to put your zeros there. There's 2 place values there. So we have to put the zeros there to be our place value holders. 4 times 4 is 16. We'll just go ahead and change that color so it's not confusing. 4 times 3 is 12, plus 1 is 13. We'll drop the 3 and carry the 1. 4 times 1 is 4, plus 1 is 5. Okay, so we're going to go ahead and add these together. We have 6, 0, 8, 4, and 5. Now, here's where our 1, 2, 3, 4 place values come in. We need to drop that decimal place value back in by moving it back to where it belongs. So your answer should be 5 and 4806. Or 5 and these are tenths. These are hundredths, these are thousandths, these are 10,000ths. So 5 and 486 10,000ths. I don't know if I said that right. That's okay. The key is to remember you moved it out 2, 3, 4, bring it back in, and then if you think about it, would 1 times 4 be 4? And then you've got some parts being multiplied as well. So is 5 and 4 tenths pretty close to 4? If you were to move your decimal to the wrong place, would 1 times 4 be close to 54? Or would 1 times 4 be close to half or 54 hundredths? So you should know that the decimal should be right there because 1 times 4 is pretty close to 5. So that might be your way to second guess or second check yourself. All right, and then we have another double-digit decimal multiplication problem. All right, so if we have 1 and 4 hundredths times 2 and 25 hundredths, let's go ahead and multiply it. Remember, we're going to say 1, 2, 3, 4. we have to come back with a 4 at the very end. All right, 5 times 4 is 20. We'll drop that 0, carry the 2. 5 times 0 is 0, add 2. 5 times 1 is 5. All right, remember, we got to add a placeholder for the 2. 2 times 4 is 8. 2 times 0 is 0. 2 times 1 is 2. All right, we need to add 2 place value holders for these two numbers. Now that we multiply the 2, 2 times 4 is 8. 2 times 0 is 0. 2 times 1 is 2. Notice that these numbers are similar because there's a 2 and a 2. All right, let's add them together. 0, 0, it's 10. Carry the 1. So we got 5, 6. 6 plus 8 is 14. Carry the 1. 1 plus 2 is 3. 2 plus nothing is 2. All right, we've got to bring that decimal place back into the picture. And then we get to the decimal right here. So it's 2 3400 is your answer. Okay, so the biggest takeaway for these multi-digit decimals is count how many times the decimal comes out. And at the end, you got to bring it back. All right, hope this helps.